We have a Perkins tractor cylinder block come in. I'll show it to you in a second. The owners have had a piston ring failure and lost one of the bores. There's some scoring in one of the bores. And that particular block is fitted with liners, thin liners. Forget the term now, non-top hat liners. And they've removed the old liners and pushed the new liners in, and they're having difficulty fitting the pistons. It's a bit of they've gone slightly the wrong way about it, but I think we can, well, I'm hoping that we can pull it all back together and get everything right for them. But one of the queries that they had is they'd bought a new set of pistons and rings, etc., all in these boxes, and they measured the pistons and they found them to be slightly different sizes, which was a bit concerning. So they've brought them to me to have a look at, along with a second set of pistons that they've ordered just in case, and asked me to mix and match and make the best setup. But I've measured the first set and they're all identical. So what I assume has happened is some people don't realise that pistons are not round. They're a sort of oval shape, especially at the skirt area, and certainly at the top as well. And so you'll find that the piston will be slightly smaller. I remember writing it myself. On this face, we got a bit of wiggle, and across here, yeah, it's gone out of adjustment. Wait a minute. Right, so we've got a very close fit there, and across there, we've got a bit of a wiggle. And this is, and they're also tapered from here to here, this being the narrow end and this being the larger diameter. So that's a smaller diameter and that's a larger diameter. And the reason for that is because there's a lot of mass of metal here, and when it gets hot it'll expand, and it's a very thin section of metal here, so there'll be much less expansion. So all the taper and everything is all calculated so that when the pistons are operating temperature, it does actually become cylindrical. So the way we measure pistons is across the gudgeon pin, 90 degrees to the gudgeon pin, or as the Americans like to call them, the wrist pin. So if we say that there is a sliding fit, here it's very loose, tight, loose. That's to take into account the mass of the piston here and here, because it'll expand more than it will here and here, which there's not very little to the piston in these areas. Anyway, so we've established that the pistons themselves are fine, and the original bore is 101 millimeters, and I'm making the pistons at 100.85 millimeters, leaving 0.15 of a millimeter difference, which I assume is the running clearance. So we want the bores to be 101 millimeters, and they're tight. I haven't looked yet, but I'm told they're very tight. They can't get the pistons in. So we're going to take a look at those next. Right, so we know for this bore the measurement needs to be 101 millimeters. So using, this is the largest standard that I have. This is 75 millimeters. It's a Moore and Wright. It's a high quality, and you can set this micrometer at 75 to be absolutely spot on accurate, and then I wound the micrometer out to 101. Not sure if you can read that. Will it focus? So the micrometer is now set at 101 millimeters, which is what we want our bore size to be. Then we take a bore gauge. This one is an old axe. That's the name, old axe. Bore gauge. It's quite nice to use. It's quite a long one compared to a lot of the Starrett Chinese type. And it's got a handle or a lever that retracts it, which makes it nice for putting down into the boards without scratching the boards up. Anyway, besides all that, we stick it in our now preset micrometer, and we can set the dial gauge to bang on 0. So with our micrometer set to 101 millimeters, we set the bore gauge up with the, can you see those yet? The relevant size pins. They're all different lengths, which we can swap out in here to give ourselves different ranges on this. We stick that in the micrometer, and we turn the dial until we've got the 0 set, and now our bore gauge is set to 101 millimeters. So that's that done. Lock that down, and then we can go over to the block, which I'm not going to pick up because it's too heavy. It's down there, the block. And we stick the micrometer, the bore gauge, in here, and we can read off the size of the bore, and we can go up and down the bore, and we can do it front to back, side to side, whatever you want to call it, and we can measure what size we've actually got. And I'm reading on this particular bore let's read what this is. 1,000. So that's 1, 2, 3. Right, okay. So we're about 2 thou too tight there. We're about 2.5 thou too tight there. And we're about 2.5 thou too tight at the bottom there. And we are 3 thou tight there. 3 thou tight there. And 2.5 thou tight on that one. I'm just going to quickly look at all the others and get a general feel. That's 3 thou. That's actually 4 thou. Quite tight that is. That's 2 thou. 1 thou. 1.5 thou. That's to size, bang on 0. It's about 1/2 thou. That's about 1 thou. So there's a bit of variation. I will need to go over it again when I start to work on the bores themselves. And what I'm going to do, for the sake of 3 thou and such is the largest, maybe 4 thou. I only quickly measured it. I'll be more accurate when I'm working on it. I'm going to hone it, so I need to take it up into a different workshop and we'll hone it out to size. Shouldn't be a problem, shouldn't take too long, and I'll come back to you when I've got it all set up and I'll record it. So, any questions? If you didn't understand anything and you'd like to know more, just ask me. Be specific in what you want to know, and I'll do my best to answer you. Anyway, that gets left alone now. That's all set and we can use it tomorrow. Anyway, thank you for watching, and I'll be back with an update on this. So be sure to subscribe so that you don't miss it. Thanks for watching.